Yeah, welcome everyone to our final lecture 16 today, the epilogue of the course. And we have been through a wild journey using Microsoft, using Google Clouds, the Amazon Web Services, did machine learning, deep learning, data mining, and different aspects of big data, challenges, and how to handle them. Now, this idea of the lecture today is really looking on what we achieved from a different perspective. We will look at some job reviews, basically, or job offers, and review them carefully and think about where is the course material in all of these job offers. And of course, we take the chance of also letting you know that we have open positions here as part of our research group, but also in the university and with our partners at Reykjavik University. But then also we should say that there's a different perspective overall in this epilogue lecture. And we'll also point to some of the, let's say, other areas where you can get more information, where you can be, basically stay online with all what we do here in Iceland, in clouds, in HPC, because there's lots of things to come. But before we go, as usual in the material of today's lecture, let us quickly review what we had the last time in the short lecture 15, which was about big data streaming. And data streams is a topic which is incredibly large, so it's something we cannot really cover in one university lecture properly. They're experts for data streams, for interactive data analysis, and so on. So it's a huge field, but nevertheless, we tried a little bit to look inside and give you some pointers where, are some directions heading. And I think one you can really imagine are the new devices, apart from social media, that everybody of you will know, is already creating a lot of big data these days. Social media, we have reviewed it also in earlier lectures about online social networking. But what's definitively coming up and contributing to more and more big data are these things like the square kilometer array, the large measurement devices, or simulation devices with the big data generated maybe just by computing and simulating something like here in astrophysics simulation, or as we learned in one of the previous lectures with computational fluid dynamics. And this is in the orders of petabytes, and 1 petabyte is, for instance, a brain that is coming up, right? So, well, people in the past in neuroscience have worked on data. For instance, if you Google the big brain, you will see that's a terabyte brain. Many years ago. Now we have much more sensors to have the human brain much more intensively studies going to a petabyte and growing more and more. So this is definitely something we have to live with. And then the streaming effect is, of course, making this more challenging even, so that you have to have some filters in the future, as you basically have also already in the past. If you think about CERN and their big experiments in physics, they have huge filters before they even start the data analysis. There's a HPC system directly connected to the initial stream that filters out a lot, because essentially it would be by far too much to store everything. And these are just examples, for data streams. An interesting other data stream, which is sometimes under-expected a little bit, are essentially the ideas of crowdsourcing. And the ideas here, of course, not only by paying in a crowdsourced manner for books, for movies, also about citizen scientists, for example, right? There are lots of them, and they can, of course, contribute to lots of data, even if the data maybe has a relatively low trust because they're not experienced in their field. Still, the collective knowledge, or basically the power of so many that contribute, let's say, and make pictures of a specific flower in the field from all different angles, let us, of course, more study different parts, or at certain events, if think again the Nordic Lights, or something which is just not every time every day there, so people that really intensively take time to make pictures of this. Of course, then the hobby scientist that is then lying at the seas here in Iceland at night, and then having a footage or basically a video from all night of the Nordic Lights, this is also appreciated, but they're less in numbers, right? Not everybody is willing to lie there all night and doing these pictures. But of course, they have already moderate trust. These are experts. They know where they usually happen. They know basically how to do best some high resolution images or videos from them. So this is also something which is already perhaps in the petabytes domain, while of course a citizen scientist data is in a sense overwhelming, going to exabytes and much larger repositories, is particularly in the light of the fact that we have all smartphones with unbelievable good resolutions these days to do pictures just ad hoc. So all of these are interesting data streams, and if you compare it to the scientific domain experts, which maybe create data, scientists are just rare in the world, right? We are not the major population and the engineers. So in this sense, you have a very high trust of data generation, but not, let's say, every 10th in the population here is an expert, let's say, in computation, fluid dynamics to study turbulence. So these are the facts that we face essentially from different types of data streams. And we have seen there are lots of different applications and tools around. One that we often discuss was sentiment analysis with Twitter, thinking about good or bad publicity about your product maybe. And you want to have tools for it which actually can cope with the high speed and velocity that is really there inside these streams. And Twitter is a very good example. You see that today by a couple of examples from me again. And the interesting thing is that whatever you learned already at the beginning of the course for using HD Insight with logistic regression with Spark, and then the MLlib, you can apply the same thing now. You're just one step away. Instead of using the MLlib that you used before in the previous or earlier lectures, basically in the course, you now use another library based on Spark, and you would do the same PySpark notebooks, deploy that on the Azure portal as we learned already. So you see it's very powerful, and one step away is just another very beautiful API to work with streams. And then on the other hand, you also have learned, for instance, the Amazon Web Service is quite intense now. You know how it roughly operates. You have seen some lower level service creating key pairs using EC2, maybe the AMI image, if you remember a little bit, so virtualization. But you can have also cutting edge tools in Amazon. Of course, it depends on your pocket. How much money do you have in the pocket? You realize this once you go out of this course and not stay in academics. Then, of course, you will go into the field of you have to pay for what you use, which is a key idea of clouds. But we have seen there's Amazon EMR, Elastic MapReduce. So this means you can have the whole Apache stacks, including Apache Spark and the streaming API beautifully supported there as well. Or, as we also see in the last lecture, really, as a particular highlight of what is an interesting service, which quite some automatic features and a very powerful suite, is the Amazon Kinesis. So it's going a little bit beyond when you want to work with streams and have already, let's say, very prepared setups for working, for instance, with video streams. We have seen the truck basically with sensors and having already tailored let's say services, which could be really nice working with this. In the video example you see here below, once you have the video stream, put it in the Kinesis video streams, you can quickly connect it to recognition video services on Amazon, maybe making your own security camera in front of the company. Or an Amazon SageMaker, where we have learned already in one of the previous courses, a nice SaaS service to really do data analysis much more intensive. You learned about TensorFlow, so deep learning, of course, is just around the corner. In Rocco's and Gabrielle's lectures, you have seen how powerful deep learning is these days with image data. Now you can imagine if you have a video, which is nothing else essentially than a kind of series of images, you can do a lot of things as well. And you can go on and go on. Amazon Kinesis is great, but what about when you have not so much money, when you're a startup and you want to do some streaming and you have a couple of resources somewhere that you get maybe, there's of course a large open source domain as well. And these are just two examples I bring here, which are often used together: Apache Kafka, Apache Flink, where while Kafka is much more a brokering and actually streaming platform, you can there put different tools on. For instance, one idea would be Apache Flink, but we also have reviewed the fact again. So Apache Flink lives from in-memory solutions, but when you have in-memory, the problem is you have to have a resource which also has so much megabytes or gigabytes of memory. So in this sense, you maybe want to use Apache Storm, just more traditional one, which is not relying so much on memory. So you see there's lots of open source technologies and tools available for streaming as well. and talking about all the different approaches, because all of them have their little unique selling proposition, like Apache Flume with the event analysis, for instance. There were different ones, and of course they have a huge community behind it that also is therefore used by many companies out there. But that's it really for the content. I think, as I said and showed to you, this is a really huge topic and we can't go in all the details. So with this, we have to congratulate now all of us that we have achieved the course, all the kind of real substance topic. The epilogue is now just thinking about a little bit a different perspective, what you can do with the contents here, where do you get more information, where you stay connected to the community. Because I think in one way or another, maybe through Wolfgang Gensch with UberCloud, you have realized this HPC and cloud community is in the end rather small. We know each other. So, and this is particularly true because there's several key conferences I will come to at the end, the supercomputing, for instance, where people gather in the community. It's 15,000 people, 16,000 people sometimes, but the chances are that you maybe not know everyone, that's clear, but the friend of a friend is a friend of you. And so that's why this community is just a very strong community. And I would also personally add a very interesting community, of course, being there already 16 years and basically consider myself really an active driver also of this community. But before I come into this, let us just review first what we actually want to do with this epilogue. And of course, on top of things, I would like to thank all of you for joining me here. It was the first time in Canvas, moving here to Iceland in between, which was also quite challenging sometimes, particularly in the light of COVID-19. So it wasn't easy for me, but I guess for you also, having no fellow students, and I remember recent discussions with students, I don't know even the room of the exam, that there's a math exam in some room, and of course people never have been to the university. So how do they should know where the room is when everything was remote in the past? So I think all of you are really have to have also, I mean, a big thank you that you stayed connected to this course. You made it to the end. Now all what's left is a little bit the exam, but I hope we already started preparing for this with the quizzes. We have good quality material that you can review, not only basically in slide form. We also, with the remote teaching and COVID-19, took the chance now of creating YouTube channels with, having also then this all in video, hoping to help you in all possible ways. So it's really an informal final lecture. It's not exam relevant. Still, later on, we will do a quizzes debrief and so on, and then of course this becomes exam relevant. We will talk a bit about your mindset, so job offers, where in which direction you can look within Iceland, and of course more internationally. And think about what we have learned in terms of maps, what we have now in our mind, and of course what we can apply as part of our skill set. So you have learned incredibly much cloud system techniques, and with this indirect skills like parallel computing, what is basically every now and then in this course coming up to basically to the surface, right? We learned about divide and conquer, map reduce, all parallel computing. So HPC and cloud, machine and deep learning topics are so close and intertwined together these days that with the knowledge and skill set that you have in this course, you have very good chances on the job market to basically get such a job before someone gets it that never heard from these tools and technologies or never used them. You applied it in practice, in clouds, in real clouds, not just fake, let's say, small Openstack installation somewhere. You have it basically done in AWS services, which are world-known, MS Azure, in real cloud environments, and Google Colab is just another one. And with this, and also turning the perspective of being maybe more a kind of administrator, more developer, we had the Google App Engine, we had OpenStack, right? Create your own cloud. So these are all topics which are highly wanted on the job market if you go to any job brokering, and we will review a couple of them for you as pointers. Of course, we already at the next steps here. One of my PhD students and also Gabrielle that you know here from the lectures, we already work with quantum computing. So we basically go ahead. We use support vector machines, on quantum computers like basically D-Wave, quantum annealing based. And you see this will carry on. The technology will not stop here. We will have new technologies, and that makes it really excited. But many of the techniques and the skill set that you learned will be also equally applied in the future. There's several computing paradigms that will test the stand of time. They're just differently implemented with technologies. With this a little bit to the outline, we will look at cloud computing and big data really from this perspective. So what is there now, what you learned, what will be possibly also in 10 years' time there? There will be further readings, jobs reviews, as I already announced, but also, of course, thinking about that we have some jobs, if you're interested here, as part of our research group or within the university and University of Reykjavik as well. High performance computing, the next course, we agreed now basically with the setup of all the courses. It's always not an easy schedule to do, that the high performance computing that I teach will be in spring 2021, and it's a highly complementary course to this one. It's a little bit more technical, but it is essentially covering a lot of elements you already indirectly learned. So I think the learning curve here is a little bit advanced if you would take this course. And of course, finally, most notably, perhaps acknowledgements to my team members that take a lot of work from my back and actually explore lots of elements. You know, Rocco here in the call, he is doing incredibly work with Horobot to make all the packages right and so on. Without that, I could never sometimes do tutorials or work on the sciences. So it is also important to acknowledge the team, what I hereby also do, and also point to some upcoming events at the university, which are also very positive. We have another PhD finishing, which is quite nice. And so, of course, this epilogue is a little bit personal, right? So in this, I'm sorry for that. But in the end, it was a course that I delivered here for you. And certainly these are my perspectives. If you go out there to other people, to other players in the field, they would have different perspectives, right? So my perspective here is, of course, biased from me being 16 years in this community and here also in Iceland, together also in Germany. So when we look back to the course motivation, we said parallel processing, distributed computing. This is something what this course will offer. You can imagine now what you have done was a lot of distributed computing all the time. Indirectly under the hood was Spark often, which does automatically parallel processing. And we had a kind of comprehensive approach, which means we don't really look at single individual pieces. We really wanted to know and see how we can really use AWS, but then not for a ping or for a, I don't know, hello world. We wanted to use it with something which makes sense with the big data. And by now we have basically used essentially deep learning already in practice. You have used artificial neural networks with a real problem of image recognition. And you have done the full chain in logistic regressions with pipelines of feature engineering. So this is, of course, a very important part, that you don't learn the things individually. But I guess with this knowledge now, you can actually go to a company and really turn your elements here into practice. We had latest advances, so eventually you will notice that the slides I was pointing you at the beginning of the course for 2 years ago, 2018, I significantly updated them. Just 2 years means a lot in cloud computing. Many of the processing elements will stay, and as I said, they have some momentum, like HPC and HTC paradigms. They will always be there. But of course, some of the technologies, of the tools, of the services, and all of these different offerings from AWS and so on, they advance quickly as well. So of course, here you see really you got a course for latest advances all over the whole different cloud stacks, including, and of course, also the academic ones. European Open Science Cloud is a very recent endeavor, strategically planned a long time, but now we really see the first services being available through UDAT. If you remember, B2Share, B2Drop, these are really existing now for researchers without charge. And this is, of course, an important part. We also looked in the prologue a little bit on what you should understand when you're here in this course. And I mean, now you have done parallel processing. It's, a bit repeating what we of course planned as a motivation. You have created high performance clusters with Spark now. You know how to do it. You need a template, worker nodes, and a master node. The same for scalable machine learning. Scalability was part of almost every couple of lectures to understand that this is a benefit of cloud. right? That's why I do cloud computing. I want to have this elastic capability, shrink and grow, depending on demand and of the sizes of big data. Automated computing, we have seen it contrast a little bit to HPC perhaps, and these courses that will come basically in spring, you will see that more and more things can be automated. The pipelines we did with logistic regression essentially has a lot of automatism inside, and this is of course really beautiful. If you use things like Kinesis, we just discussed, is another example, or SageMaker with the IDE for machine learning, lots of automated computing underneath where you essentially don't really touch the computer. The same with SaaS offerings, which are extremely powerful, having recommendations in machine learning. All of that was, of course, interesting. And what you have learned. So from this web scale clouds, really, we looked then towards the end also to online social networks and graphs, so topics which are, let's say, huge on their own. So graph theory, graph technologies would fill a complete university course. So that's why we just touched on it with one basically university lecture. And with this, I think you're ready for doing machine learning and deep learning. You can do data mining, you can analyze shop data by now, you have learned this, you can have a reasonable recommendation engine, that's what you did in the assignment, and actually can now work with clouds to really handle big data, which was the goal of this course. And I think all of you are now capable of doing so. Now, when we look now as a summary, perhaps, on all of these, which will remain, perhaps, right? What are the substance elements of the course which go beyond logos and names, which are actually extraordinary much in the cloud computing course? But that's just because, you know, there's a huge market outside, as we see in the job market space. So from the theory, we had parallel algorithms. We used basically then things like Spark. They had parallel implementations of, you know, using elements like logistic regression in the MLlib, or parallel algorithms with Horowot, and then scaling deep learning networks. We think about speed up every now and then. You remember 96 GPUs together actually achieve scalability and had done a deep learning 50, you know, ResNet 50 really much faster trained as possible before. And you have seen and did it in your assignments, essentially using the CNN and then before the ANN, and have seen when we put the CNN suddenly on the GPU, how much more quicker it is in the Google Colab. So these are interesting things in theory that's remain wherever we will go in the future. There will be always errors. There will be always faults, things you already learned very early in the course with the data centers, right? That's why actually Apache Hadoop, the Hadoop distributed file systems were created, because we knew that large data centers at that time, they will always fail. So basically assume fault automatically was one of the design paradigms. And by having these faults all the time, we need to measure it, we have to understand it and see how we can, let's say, counterbalance it. Data mining algorithms was a little bit theoretical, of course, with a priori FP growth, and perhaps a little bit the recommendation engines, which then already reached a little bit to statistical learning theory, elements of why can we learn, why we need a training and a test set, why we just don't train on all the data and then we're done. We have to check ourselves. We have to do fine tuning of parameters, this so-called hyperparameter tuning. You have to understand how much data is there and which model I can use for it. But these are all more advanced than topics where you really should maybe study in the future if you're really seriously interested into, you know, this field of machine learning and deep learning, which is a very large field with lots of jobs offers as well. So from the techniques, what are now the specific techniques when you think about cloud computing? And it's for sure one that is economics of scale. So why it makes sense now for, you know, startups or for companies to go to the cloud? It is because they don't have the big seller where they can put all the computing in and then actually scale with the size and then offer operations on a quite minimum cost, because this is really what behind economics of scale. So this large cloud vendors that you see out there, they really apply this model, and with this can have quite competitive prices that you not really can so simply reproduce. You have to hire people, you have to have the location, you have to think about the cooling, you know the game. We have seen in memory optimizations, this was in Apache Spark very early on and recently in Apache Flink. And when you go there, you have learned that memory is the fastest you can have together with caches. So that's why you want to optimize towards these directions. Do as much as you can in memory. And you will see, perhaps when you study these topics more deeply, that GPUs also have HBM. They have specific type of memories, which makes it also very fast. So this is a kind of technique that stands the test of time. And the paradigm we learned, maybe it's not always good to put actually basically the compute to the data side. Maybe it's also good that the data sometimes move to the compute side, even if it's just smaller chunks with high throughput. So these techniques of putting these two actually alongside each other, depending on your geographical location in the company, is also a technique, of course, what you have to always remember. Does it make sense to transfer petabytes of data, or do you maybe have rather small computing entities and distribute them in different factors over, let's say, all the different branches of your organization? So things where this replication and so on with the distributed file system also comes in, which is mentioned also later as an interesting technique, of course, that you have learned in this course. Replication strategies, Amazon with the 99.99999 availability of data achieved through replication all over the world. And a specific technique for private public clouds, hybrid clouds. You have seen sensitive data I put perhaps in a private cloud. Public clouds are quite strong in computing for unsensitive aspects and quite competitive in price. And when you combine them, you have the hybrid clouds. And it's also a technique incredibly useful and also actually stand the test of time. And of course, it goes without saying, all of these aspects essentially in one way or another touching on virtualization. The infrastructure underneath is of course the most important, because without that, you would never achieve anything. You need the infrastructure. And with virtualization, we have learned that this is a very dynamic, interesting infrastructure, which then can have, an interesting load satisfied between different multi-users, multi-companies, and geographical locations. Perhaps a bit on paradigms, high throughput computing, high performance computing. This should be all clear by now. The one is more optimized on throughput, so smaller computing, but hell, a lot of that. And high performance computing with high single thread performance, or really large number crunches, which still have the playing field, for instance, in weather forecast and so on. You learned about the divide and conquer via MapReduce, which means essentially a very old computer science paradigm, divide and conquer, which today is still equally applied. Now with MapReduce, sometimes in Spark with different mechanisms, which is very similar than MapReduce. And of course, all the paradigms you learned, the infrastructure as a service using virtualization, the platform for developers, right? Really creating some Lego bricks that then people as in a platform can use to create their fantastic Lego model. And then the software as a service, which extract from all the Lego pieces you don't want to know about anything, or you don't want to know about computing. That's all already inside somewhere. I just swipe my credit card. So basically these are the paradigms, and I think this is what will remain. Some further readings, I don't go too much of it. I provide you all the references, and I just want to not to bore you and you want to come to the test exam. Instead, it's just for those of you who are seriously interested in this course, please feel free to look at all of these books or references. I think this one is a particularly interesting one if you want to have cloud computing with machine learning, but the other ones are also equally interesting. We have a very lively community. That's why also partly as being part of this community and maybe here a contact point for you all in Iceland, you always can look at my web pages. I usually post very actively about teaching. You see just another class in between the teaching here in this class. I had another basically full day of neural networks. I teach for a very particular class of PhD students, 30 or 40. There is resources available on my teaching website. And if you scroll down, you see more and more. You have Twitter tweets where you have different aspects. You see a little bit here, work with CERN maybe 10 years ago about grids and cloud computing. Well, that was the start of clouds at that time. We just did grid computing then. So maybe interesting aspects to look at, but it's a bit too much self-marketing, so I want to go on here. The YouTube channel with all your lectures, share with fellow students where you maybe create a startup and really want to use Amazon Web Services. Make it known. It's of course a resource from the university really for everyone here that we have created essentially together. And then of course my Facebook post, you see here, I post also about future courses, like high performance computing in the past, I will do so for the new one that is coming. Even if you're not enrolled in the university anymore and are in the job market, usually our slides and recordings will be all free so that you can always look at that. Coming to some selected jobs review, and here I could talk hours, and I think you're smart enough to look into the web. By now you will see where you can find good jobs. I just wanted to make a couple of examples here which are related to Iceland. For instance, you see speech recognition experts, so using machine learning, deep learning models now also for speech recognition are highly popular, and you have just 2 examples from Reykjavik University where you could apply. And of course, I could give you a recommendation being part of this course, consider that, but also the material you learn makes you already a bit more advanced than maybe others that never really touched on machine learning before. Okay, here's an assistant professor, which might be a little bit too high. Maybe 1 or 2 PhD students that maybe consider it. Just showing you that, of course, it will have also impact in other fields like electrical power engineering. On the right-hand side, you see then, when I just put cloud in the so-called Glassdoor job market in Iceland, you will see alone interesting NetApp aspects here of this company that is here in Iceland that is actually hiring. And if you go down and scroll down, you will see words like IAAS, SAAS, and PAAS, and so on, and things you learned. So basically, you're ready for this to apply, and of course have a perhaps better chance really than you did not with this course. Openstack was a big topic, maybe shifting away now from deep learning. That's very clear that there are lots of jobs shifting away from clouds. It's a hype topic, so lots of things. This is a very precise example where maybe when you go outside, right, beyond Iceland perhaps, you're thinking about this here, another LinkedIn job possibility. So LinkedIn has a really good job overview. You see lots of interesting aspects around jobs. So here it's a bit biased with Germany, I'm sorry for that, but you see actively recruiting, DevOps, so cloud DevOps, engineer, OpenStack experts I wanted. And if you look into this descriptions here, of course, then they would be not in German, but you will see, of course, when you are tipping here another country like Sweden, for example, with our Nordic friends, you will see a hell of a lot of others. Job opportunities when you put all of these lectures essentially and try to really here put them a little bit into this job brokers. Just because, we're talking about jobs, we are also hiring. We have always, of course, master thesis topics available if you want around data science, cloud, machine learning, and so on. And this is, of course, one example. We have our courses here if you're interested as well. But in the moment, we have also very active, search going on for a couple of PhD positions. Here's one, for instance, here in Iceland about remote sensing, together with Gabriel, that you know. We're searching, and Magnus actually from the electrical engineering, we search for 1 PhD student. So maybe get that known to your friends and colleagues who would be perhaps interesting to join us as a interesting and funny endeavor. You see here, it's not always very much work. We also have lots of celebrations. This was last year our Christmas event, so feel free to join us as a great team. That is a really nice set of colleagues that you see there. Shadi and Rocco you already had from the invited lectures, as well as Gabriel, and these are 2 PhDs that actually finished last year, and the gentleman here in front will finish this year. So just to say that, of course, we are here as well at the university also in the future when you finish the course. So in this sense, consider maybe this course, because I think you have many of the requirements for this already. There we look a little bit under the hood. We think about parallel computing really differently. So you see here smoke, for instance, in certain devices. So we will analyze how you do this with finite elements, with adaptive mesh refinements, and how you can distribute this on different processors. We will interconnect different earth science models. Here you see groundwater modeling together with the land surface and then also with the atmosphere. And there we're really thinking a little bit of, really deep technologies, which are essentially this red part, but then also many domain-specific science and engineering problems we will look at in this course. So it's a little bit different from cloud computing. Of course, that's why it's another course, but some of the inherent designs you already have learned as part of this course. Right, so yeah, towards the end, really, of this course, essentially, without mentioning now the exam, which is another part of it. I have to thank also all my students that you have seen here. Still going back to aspects where I use elements from this gentleman that created this deep learning startup, if you remember, with other friends, Soccer Watch TV. Then another PhD finished here where we use still his algorithms from 2018, DebiScan in practice. And this gentleman you already know here, we already talked about them. So with this, I'm really thankful, especially, of course, for now Shadi, Rocco, and Gabriel, because they also delivered here an invited lecture from their really good experience in the field. And also PhD student has lots of things to do. A postdoc like Gabriel has even more massive things to do. So in this sense, I'm also grateful that they spent the time here and connect with you. Here you see also a history, right? Gabriel graduated himself from the University of Iceland as PhD. Rocco and Shadi here, you see in the medical domain a little bit with me, as he was alluding to in his lecture, those are active PhD students and they're around. Maybe you can contact them and they can show you what is it like to be a PhD student, to publish, to present, to write papers, and every now and then give a lecture. So for those that are interested in the academic life, I think here you see very good examples of what it will be for you. Just for the future, you will have always my Facebook page, Twitter page where we're active. The university itself has, of course, pages. Here you see where I would like to invite you on the 18th of December. One of my PhD, Shiraz Memon, is getting finished with his thesis, and he concludes his PhD with a talk at that location. It's probably, I guess, rather online, so we will also share their news basically then on social media. But you see here past events from 7 years ago on Facebook here, where I was once invited to talk 7 years ago about big data, or just last year at a big medical convention, which is worldwide known. So you see, being active in this community really pays off. It's a really lively community. There's always something happening. And when you want to look a little bit in the past, you essentially see here a very nice video from the community of HPC and cloud computing, which is more or less really intertwined these days. You see how it started, what was happening left and right in interesting world aspects. Think about that. We never knew a GPU would be conquering the world in computing. It was just a small graphic chip. And now it's a general purpose motor or vehicle of deep learning. So these are things which is just 10 years or 15 years ago you would never imagined. And this will continue. I think the breakthroughs we probably also very soon have already with quantum annealing, quantum computing, optimization just on one click, and things like that. Nearly a massive increase in speed in computing. But this is a leave to you to check. And again, thank you very much. That's my really last lecture here in this course. Thank you for your engagement in the course. See you next time.